Okay, so coming from ELISA, a bit like first look at our history, like how we came involved and what was like our journey in the automation and AI side, and then I will take some more recent examples how we have been pushing for new growth with applying AI into new adjacent business areas as well. So starting from the history and then coming to today and a bit like forward looking as well, what has been our AI story so far. ELISA is still primarily a telecommunication operator. We are operating in Finland and Estonia, but we also have around 1,000 people in different international software businesses. In that area, we serve other telecom operators with automation and AI solutions, but we also have more than 1,000 industrial manufacturing customers in different data-oriented services, and then the most recent expansion is towards the energy management. We are in European comparison 10 years of steady profitability growth, and 5G has been, from monetization perspective, very good success for us as well, and from that perspective quite unusual aspect, and it's even more unusual when we consider that our capex ratio of revenues is on the low side of the industry, only 12% of the revenues. And our secret sauce in this area that we are totally willing to tell everyone that is interested to hear is that we have been investing in the automation and in the recent half a decade AI development a lot on how we operate the networks. And from that perspective, like it has been the automation related development that has allowed us to operate the infrastructure more effectively than what would be like typical in the telco industry, and that we have been able to then leverage and how we have been doing the product pricing to capture market share and keep the profitability in that side. So that's like high level, like the primary story of ELISA's last decade of automation and AI development. And if we go into a bit more details here, the background goes around 2008, 2009 into actual business decision. At that point of time, we thought that the data-based pricing is rather hostile or unfriendly for the end users. Like at the same time when we hoped they would be consuming a lot of the data to enjoy all the services with the internet and mobile internet and really get like the benefits from the subscriptions we want to provide them, like then if we start to penalize the users when they actually do what we want them to do, meaning actively use the services, like we felt that that's not the right way. And then the alternative that we first trialed and then expanded across the service portfolio was speed-based hiring. So started on the 4G era, that instead of these like data caps and pricing for the extra data, we have different unlimited plans with different speed tiers. And that has been working really well for the past 15 years. So we have always like the different speed tiers available, all unlimited data, end users can enjoy unlimited internet usage, and then depending on the purchase preferences and so on of the end users, they can just like select the speed levels that are like best matching their preferences. And this has been like really for the 4G era and now for the 5G era serving us really well. And that's like now after the fact that that business decision was a good one and it has been like allowed us to do the profitable growth. But when we go back to this around the time frame of 2009, all the analysts, all the consultants and industry experts were saying that this will be like mission impossible. You will be exploding the data usage growth. You will need to invest so much on the radio access network hardware that like the case becomes profitable and you will be just like mismanaging your business like totally. So that was like the advice at that point of time. And it is true that we took that like very seriously and we started to re-implement and rethink how we operate the infrastructure. And in essence, we took the data layer of like how we operate the infrastructure away from the traditional technology-based silos and really like unifying that we are able to monitor and control and optimize the whole chain of the technologies required in the end-to-end connectivity. And we started to build that layer ourselves, and then after that here are some of the milestones over years, like how we have been then expanding and making that operational layer more and more effective, more and more optimized, and then in the recent years more and more AI-driven as well. So this has been like the main driver that for the automation and AI development, it was this business choice that was driving us into situation where we had to excel in these kind of things to make it work in reality, and it has been serving us well. But then there is the other item that it has allowed us to start diversify into related other opportunities. Of course, like we can do similar solutions for other operators. That is the ELISA Polystar part of our portfolio, and that is maybe like the easiest to like understand. But then there is also the ELISA industry part where we solve similar kind of operational data-heavy issues for manufacturing industry clients. For example, we are one of the leaders in semiconductor manufacturing quality control systems. So like, and in that area, there are multiple different like manufacturing technologies, and then it is repeated for the chip to be completed, like hundreds of processing steps happening over many weeks of time, and really being able to monitor and control that process as precisely as possible is key for having high yield rates and being able to minimize like the scrapped modules as early in the manufacturing process as possible. So we have been expanding for those kind of areas where there's a heavy data processing related decision making happening and where we can then start to automate and optimize both with traditional means and then with the AI, the operational processes. So that has been like our journey, and the very latest is how we are applying this on the energy side, but I will take a bit like case study or like few aspects of that like later in today's presentation. And now with that background, like we had internal work, like looking backwards that what was and was not working in our own operations. So this is not the forward-looking statement. This is like how we like after the fact, what we concluded were like the key success factors why some of the project teams were successful and others not so. And if I start here on the building blocks, first is that it's surprisingly easy to miss and be unclear on what is the customer problem to be sorted out on, what is the business value to be like created. It's so easy in AI development to see the latest fancy tools and then start applying the fancy tools without having like clear direction in mind that what is really the core problem to be sorted out. And after the fact for us, like this is what we see as one of the building blocks, that one needs to be pruning down the application areas and being really like intellectually honest on what is the real value to be delivered and whether we are able to address that, be it with more traditional automation tools or with more modern fancy AI tooling in place. But like really like questioning that are we delivering new value here before going for the more tool technology oriented approach. Then second is that on all the good success cases, we have had the domain experts, for example, radio network engineers, and then software specialists, and then AI data engineering specialists, like working really tightly together. And how to build these kind of multidisciplinary teams so that they understand each other's language, know each other's like strengths, and like are really able to work as one unified team. That is like the second key success factor that we have like identified. It's really easy in large organization to go for this like functional split that you have the specialists of one kind working together in a functionally divided organization, and in our experience that is the wrong way. That at least like for spearheading the new development, you really need to have all the key competencies placed in the same team, and you need to be able to build and inject the right kind of competencies into the team as early on as possible. And this is something that we have been like practicing from many angles. Nowadays, I would say each and every of our radio network engineers has a pretty decent level of basic programming and also data science skills as well. So like Python is like commonly used across the teams, and it doesn't mean that we are trying to create data science experts out of the radio experts or the vice versa, but there needs to be enough of the skill overlap so that people are able to like work together and recognize each other's like special deep know-how. And then if I move forward on this ready to renew processes and business models, like in our experience, if you don't change the operational process at the same time, it's very rare that the technical solution only would bring you the productivity benefits. And from that perspective, if we take the process as set in stone and try then to just like improve the process performance without redoing any parts of the process, it's a bit like trying to do 100 meters sprint race with like rubber boots on your feet. And really like allowing the teams to experiment and really be empowered to also change the operational process is something that we feel that like we are pushing the empowerment really down in our flat organization, and empowering the teams like really strongly, giving like the accountability and also the authorization to change things into the like down in the organization. So we feel that is like culturally important aspect of making this work. And then the last of these key building blocks is the data layer. And this is not something where we would be always in rock solid situation. It's more on the contrary that like we have like managed to do excellent things, but on the data layer, like there are always things that can be improved and that can and should be like developed systematically forward. And at least so far for us, like all the improvements we have been able to do in that area, they have helped the overall performance, and from that perspective, like we have definitely not like saturated the potential of improvements in that area. And it's easy to find cases that were stuck or very ineffective to implement or slow to scale because the root causes were like limitations in accessing the data and making like the be it technology vendor silos or organizational silos, like if the data is siloed in some way, it tends to make the development of the automation and AI like very difficult. So investing enough on the planning and improving the operational capabilities of the data layer would be our fourth key success factor. And then just as like one anecdote, we have been protecting our innovations, and for example in our home market in Finland we have been consistently in the top 10 most active organizations patenting their innovations with patents, and the share of patents in our portfolio that are like utilizing AI as part of the overall solution has increased to more than half of all the cases since several years already. So it's like one indication how the share of the applied technologies has been changing over the years. And of course, our automation journey is like much longer than this recent 5 years. So this is more just highlighting like where the tools at focus in the recent years has been. And then for the second part of the presentation, I will take a bit more recent case study, what we have been doing on the control of energy systems. The background here is that if we take a wider look on what's happening on the energy with regard to the climate change, like the positive news is that wind and solar are already today, depending on the geography, the most inexpensive sources of electricity generation. So that's wonderful news. And then comes the bad part. And the bad part is that it used to be so that the balancing of production and consumption was traditionally done fully on the production side. With fossil fuel-based generation, it was rather easy to either burn more or less of the coal or natural gas or similar kind of things. And from that perspective, the whole electricity system was controlled essentially on the production side, adjusting like how much fossils you burn. And if and when we get rid of the fossil-based production, this balancing capacity needs to be done in some different means, because wind will be very erratic and it will be like blowing when it is blowing, and solar will be following the daily cycles and the weather cycles as well. So both wind and solar are very like variable sources of production. And in the broad scheme of things, what the electricity system requires is new sources of flexibility that help matching the production and consumption. And we thought that, hey, we could start applying like what this future needs from our own infrastructure. And that's what we did. So like we have been upgrading the traditional lead acid batteries that were in the radio access network for the resilience perspective with lithium-ion batteries. And we at the same time we have doubled or tripled the capacity of those lithium-ion batteries compared to the resilience requirements. And then what we did, we built the AI control system that is able to adjust the consumption of each and every of our base station sites every second. We can either increase the consumption by not only taking from the grid the energy that the radios require, but also extra energy in so that we are charging the batteries. Or we can do the vice versa. We can reduce the consumption by not taking any energy from the grid, but we take the energy that the radios require from the batteries. So we are able to adjust the consumption upwards and downwards, and we are able to do this for thousands of sites. And what we do is that we aggregate this together, and then we have this flexibility capacity offered both on the electricity market, so optimization of the procurement profile, but we also offer this as in so-called electricity ancillary services market as a service for the electricity grid transmission system operators that are responsible of keeping the grid in balance. So this is a service product where the adjustment capacity is offered for the TSOs in that market. So that's what we did. And if I dig a tiny bit deeper from the benefits perspective, first is that like from these new revenue sources and the optimization of the electricity procurement, we are able to gain very direct financial gains. And if we compare the financial gains to what we pay of the electricity for the radio network operations, it's 50% and in some years even more. Then the second is that now, because we are able to justify the investment on the batteries with the revenues that we are gaining from the energy market side, we are able to invest in larger physical battery capacity than what was traditionally the case. And in effect, then we have more of those batteries. They are typically not there at the minimum level required for the resilience perspective, but they are somewhere there between that point and the full battery. And the end result is that our network resiliency is significantly, meaning on average around 2 times more than what the regulatory requirements are, and at peak times we can push that into 4 times more. And then if we do a bit traffic prioritization and those kind of activities, then we can push that into 6, even 10 times more than what the regulatory requirements are. So all, in this kind of environment where the extreme weather events are increasing and there are all kind of disturbances happening, it's wonderful thing to be able to serve our end users and the society in more and more reliable way. And then the third item is that this is also pushing forward the sustainability. We consume more of fully renewable-based energy, and we avoid consumption on those times when fossil fuel-based production is required. Nordics are in a good situation in the sense that we are almost totally get rid of the fossil fuel-based production. So this effect is nowadays less than with the example calculations, just because the grid is so green here. But if we look Central Europe, a significant part of all the electricity is done based on fossil fuels, natural gas, and often coal as well. And from that perspective, this effect is definitely something that is there from European perspective. But then coming to this optimization and looking a tiny bit deeper, that where does the AI in this kind of new business case play in? Here is the different kind of value elements and benefits that this distributed energy storage virtual power plant system is able to do. Top right hand side, the energy procurement, that is typically the easiest. So in essence, we are able to optimize that we take more inexpensive energy in, avoid purchasing expensive energy. We are able to have because flexibility in our consumption, we are able to leverage that for our financial gain in the energy procurement side. But of the financial benefits, this is only for our past a bit more than a year of operation. This is only roughly 15% of the economic gains. And actually 80% or 80+% of the economic gains is coming from the top left corner. So how we offer different services for the electricity grid balancing perspective. That long list of acronyms is the product names that the energy industry has defined. They are equally bad like telcos in inventing acronyms for absolutely everything. But that's the range of products that is out there. And that is what is making the majority of the economic benefits. And also this is now the key part of the optimization, that every single day we need to plan in advance that what are the market conditions across these markets and the procurement side. And we need to decide that how we split for the next day the capacity allocations and how we set the price points and how we do the automated trading for this flexibility capacity. So every single day we have an operational loop where we simulate the market condition, determine the best possible capacity allocation, execute the transactions in the markets, and then finalize the flexibility plan for the next day. And then every day we need to execute on the plan that was prepared in the previous day as well. So that's the main loop. Then we have other smaller economic elements on the minimization of the imbalance fees and optimization of the grid tariffs. And then we have the resilience and environmental benefits that we discussed a bit like earlier. So all in all, it's this kind of economic optimization is at the very heart of the product, and we felt that with our previous experience of doing the operational AI, especially around the radio network operations side, that like we would be in a good position to develop these kind of new applications, and that has been the case. We have been able to proceed in surprisingly fast pace forward. Then for the last words before possible questions from the audience, like all in all, if we think about this AI development and even this kind of like AI first thinking on how to like operate complex systems. In this DES case, we can see that we have lots of decision making and automated decision making that is happening for the time frame of the next day. So like how we do the capacity allocations and the respective trading in the markets for the flexibility. So that's like happening, and that is like the one core aspect of the AI solution we have developed. But then there is also a second layer here that, well, after these capacity allocations have been done and we have done the commitments that relate to the market structure, if situation changes unexpectedly. For example, in Germany, in the first weeks of June, there was like one day where both wind and solar production estimates were very off from the reality, and then there were some transmission lines to France were also like blocked at the same time. And that resulted in a situation where the intraday energy prices peaked into almost 10,000 euros per megawatt hour. So that's like extreme price volatility. And if that kind of thing happens, then if you have any flexibility capacity whatsoever available on those unusual hours, it absolutely makes sense to change your predefined plan and like allocate for that unexpected opportunity all the flexibility you have. So we need to have that kind of automated sense making that, hey, now the market has significantly changed, or our operational capacity has been significantly changed. Now we need to react on that. What are then the alternatives of what we can adjust, both from financial perspective and from like what we can like manage on the system side, and then do the changes so that we get the best possible economic and operational outcome from the unexpected situation. And here like the time frame is in the hours. This is the within day decision making that we are automating. Then there is like even lower level, we are operating a fleet of thousands of base station towers, and they have all slightly different capacity configurations and slightly different consumption profiles and so on. And a part of this overall solution is the prioritization logic that when we need to have this up regulation or down regulation capacity, we need to know in roughly like 1 second decision time that which are the sites that we like select and prioritize for the up regulation and down regulation activities. So this kind of like a really automated detailed level asset control profiling. And then we have even different time frames if we look at the over months. Battery assets, they have something called battery management system, BMS, and it tends to drift the capacity estimates of the state of charts. They tend to drift over time, and every now and then, depending on the technology, roughly once per month, there's a need to do so-called recalibration, like detecting this kind of drift. And hey, here we have a small maintenance need. Luckily enough, the maintenance action can be fully automated, but doing the decision making and the identification of the problem is something that needs to be automated as well. And this is like really happening at the time scale of like for any single asset, this is like every month or every few months kind of action, but of course there is, for the overall fleet, there will be plenty of this happening every day. And then there's like the last item that for the whole investment case, we need to optimize for the profitability of the assets, and then like how is the physical capacity like degrading, that is one optimization target as well. And all in all, depending on the time frame, be it like at the second and minute level activities to like very long duration items, we have lots of decision-making points, and this AI first from our perspective is the discipline that like we take a as structured view on these required decisions as possible, and we plan in advance how we will have the data available so that we can like really automate the decision making, both doing the actual decision and then carrying out the consequences. And that would be like our way of thinking how to do AI first development for operational systems. And that was my last slide, and I'm not sure if we have time for a few questions or other audience participation.
That was terrific. How interesting. So we hear a lot about telcos needing to develop new revenue streams, and that's a really fabulous example of doing just that. You mentioned that you're interested in looking into other ways of other revenue streams. I don't know if you can share those with us, and if you can't, I understand. But I'm just wondering if there's any big lessons you learned from this that will translate into other projects.
So if I take first like this, how we are like seeking the growth from this, like this DES, it started from our own infrastructure. So from that perspective, like really like improving on the infrastructure which we invest in and which we control like directly, but it's already available for other European telecommunication operators and tower companies, and for example Telenor is customer of ours in this area, so like we are operating same setup for other operators as well, so that they get the majority of the benefits, and of course we need to get like some share ourselves as well to justify the work, but like the benefits are like getting for the operators, and we make this like really easy for them that they don't need to go for this like nitty-gritty details. This is in essence a managed service for them to
so you can scale this for other operators because you've gone through the pain.
Yeah, and we have calculated that there is like roughly 100 times ELISA's network or let's say the battery capacity in the European radio access network. So it is like times 100 growth opportunity compared to doing it in our infrastructure only. So that's one item. Then like what we have also done is that similar solution for residential customers. That's a pretty recent development. We had the soft launch in Finland in September, but now we are doing the commercial installations for the residential customers in a similar mode, that we have the technology set up, the batteries, connection to the solar panels and so on for the residential customers, and we operate this as one extended virtual power plant fleet together with our telco assets in this area. So that's like a second stream, and then when we have in the local Finnish press, like when it has been the news, like we have been getting incoming interest from especially from the commercial sector, from large building owners, that hey, like they have solar investments ongoing as well, and the energy procurement is a hot topic, and if you are doing this for your own infrastructure, like could you be doing this as a service in these other areas? Like let's see, this is still in the pilot negotiations and reasonable like early stages, but so far it feels that there will be not only the telco DES and residential DES, but there will be a commercial and industrial sector applications as well. So that's like how we have been expanding from this opportunity in our own infrastructure to actually offering this as a service for different stakeholder groups.
So endless variations on a theme, really. So now we have got a couple of questions from the audience. So Ken asks, with the different AI and machine learning decision-making systems, how do you manage consistency and the potential for inter-system or inter-time conflicts? Does that rely on supervisory AI or a human in the loop, or maybe a combination of them, or?
Wonderfully large topic item. In general, we prefer to start like with as easy setup as possible, not necessarily going for the ML as the first step, but have like reasonable optimization logic. And then we compete the methods against the baseline and like improve like gradually to more and more sophisticated decision-making models. So that's like all in all, and then it tends to mean that there is the human in the loop, hopefully not like so that it is required like 24/7, because from operational perspective that tends to be like very complex, but more so that we have the versioning of the different like for example, on this capacity allocation and like how we do the different like capacity pricing, that then we like review, we have the versioning of the algorithms that have been doing the decisions, and then we review periodically the performance and whether it needs to be like adjusted and so on. So in effect, it is human in the loop, but it's not at the, let's say, transaction level, but more so that we have like manageable risk and we manage the performance a bit like we would be looking after human people. If humans would be doing the decisions, there would be some kind of performance reviews, be it on weekly basis or monthly basis as well. So we do the same for the AI developed solutions as well.
Jukka-Pekka, we have one more question, but unfortunately we've run out of time. So you can either answer it really briefly or take it offline. Which do you prefer? Oh, maybe the question would help. How is the concept of physical and cybersecurity integrated into your DES VPP platform?
Excellent question. So like how we see and how it is also, let's say, from a regulatory perspective, we are now at the intersection of two different kinds of critical infrastructure. Critical infrastructure for the telecommunication and critical infrastructure for the energy. And from that perspective, yes, the cyber security and also the physical security are like super critical and have been like, well, we have like considered those to be super critical from the very start. Of course, like what are all the things that have been done, that's much longer answer, but it is really relevant aspect here.